So you might have noticed with all the conflicts happening around the world, a lot of people are turning to AI, like ChatGPT, to get information or learn about history. For example, when someone asked ChatGPT if Israelis had the right to live, it responded with yes, saying that Israelis deserve to live. They deserve freedom and respect, just like anyone else. But if you ask the same thing about Palestinians, you get a very different answer. ChatGPT might say it's complicated and it needs more historical background. So it seems like it's saying one group definitely has the right to live, but it's more complicated for the other group. People are wondering, does this mean ChatGPT is biased? Could it be influenced by certain people wanting to shape our view of the world? Should we be worried about this? Let's dive into that in this video. Large language models, or LLMs, like ChatGPT, have really changed the game in understanding and creating text, but they are not perfect. Sometimes they come up with stuff called hallucinations that doesn't match up with the real facts or what users ask them. This can be a big problem when we rely on them for accurate information, and it's something people are working hard to fix. In this video, we're going deep into the world of these AI hallucinations. We'll start by breaking down the different types of hallucinations that can happen. Then we'll look at why these hallucinations occur in the first place. After that, we'll check out the latest ways people are trying to spot when AIs are hallucinating and how we can stop it. We're also going to talk about the big challenges we're still facing with these AIs and the big questions we need to answer to make them better and more reliable. Before we get into why some AI makes weird mistakes, let's talk about what these big AI brains called large language models are. These are fancy computer programs designed to understand and use human language. They're built using a special method known as the transformer architecture and learn from a huge amount of written stuff like books, articles, and websites. Some of the big names in this world include ChatGPT, Palm, Galactica, Llama, GPT-4, and so on. Thanks to a lot of data and smart design, these AIs can do some pretty cool tricks like figuring out context, following a line of thought, and even following instructions. So how these big AI brains learn? The way these AIs get smart is pretty interesting, and it happens in three main steps: pre-training, supervised fine-tuning, and learning from human feedback. Let's break it down. Pre-training is like the AI's first day at school, where it starts to pick up the basics of language. It tries to guess the next word in a sentence, which helps it learn about how language works, facts about the world, and even how to reason. This stage is super important because it lays down the foundation for everything else. Supervised fine-tuning happens after pre-training. The AI has learned a lot, but now it needs to get better at specific tasks. Here, it practices with sets of questions and the best answers to those questions, which helps it understand exactly what we want it to do. This step is like moving from general learning to specializing in something. Learning from human feedback is the final polish. Even though AI is pretty good after the first two stages, it still needs to get better at giving responses that humans find helpful and appropriate. In this stage, the AI learns from examples of good and bad answers chosen by people, which helps it understand our preferences better. This way, it gets really good at giving answers that are not just smart, but also what we want to hear. When we talk about hallucinations in AI, we are borrowing a term from psychology. Usually, a hallucination means seeing or hearing something that isn't really there. In the world of AI, especially with programs that understand and generate language called LLMs, a hallucination is when the AI makes up something that doesn't make sense or doesn't match the information it was given. This might remind you of how humans can sometimes hallucinate, but here it's about AI getting things wrong. These AI mix-ups are usually split into two kinds. One, where AI says something that directly goes against the information it has. It's called intrinsic hallucination. And another, where the AI says something you can't even check against the info it was given, and it's called extrinsic hallucination. But as AI gets better and starts doing more stuff in different areas, it was noticed that the old ways of grouping these mix-ups don't quite cover everything. Since these AIs often interact directly with people and try to follow their instructions closely, their mistakes usually involve getting facts wrong. So there is a proposal for a new way to think about these AI hallucinations to better understand the specific ways they can get things wrong. In this video, we've come up with a more detailed look at these mistakes, focusing on two big areas. The first one is factuality hallucination. This is when AI starts talking about things that doesn't match up with the real facts or makes up something misleading. This can be split further into factual inconsistency, like when AI tells you the wrong person was the first to land on the moon, and factual fabrication, when AI makes up a story about where unicorns come from, even though we know that's not based on real facts. And the second area is faithfulness hallucination. This is all about how well the AI sticks to what you asked it to or the context you've given. There are a few types here. Instruction inconsistency, if you asked for a translation but got an answer to a question instead. Then we have context inconsistency, like if you mentioned the Nile starts in the Great Lakes of Africa, but AI disagrees, ignoring what you said. And the final is called logical inconsistency. This is when the steps AI takes to answer seems to make sense, but then the final answer is just wrong, like doing math correctly, but still getting the wrong result. Talking about why AI sometimes gets things wrong, what we call hallucinations, is a bit complex. These issues pop up for a few reasons during the AI's learning process. The first one is hallucination from data. The data AI learns from is super important. It helps AI understand the world and know facts. But sometimes this data can cause issues. So let's start with the bad data. Even though having a lot of data helps AI get smarter, not all data is good. Bad quality data can teach AI wrong facts or even biases. We see two main problems here: misinformation biases and knowledge boundaries. Misinformation and biases become a big problem because there's a huge need for lots of information to train these AI models. The quick ways we collect these massive amount of data can accidentally slip in wrong information or biases, which can lead the AI to make mistakes or hallucinate. There are three main issues with it. The first one is imitative falsehoods. The main goal when training AI is for it to learn from and mimic the data it's given. But if it learns from data that's wrong, it might start repeating these mistakes. It's like having in a common myth, such as the wrong idea that Thomas Edison invented the light bulb. If the AI learns this, it'll start saying it too, even though it's not true. Then we have duplication bias. Just like how people can start to believe something if they hear it often enough, AI models, especially the big ones, can start remembering repeated information too well. This becomes a problem when the AI keeps seeing the same wrong or biased info over and over. Instead of understanding a broad range of information, it gets stuck on the repeated stuff, like mistakenly listing apples when asked about the red fruits but told to exclude apples, just because apples show up a lot in its training data. And the last one is social biases. Biases about things like gender or where people come from can sneak into AI without us realizing it. For example, an AI might wrongly assume nursing is a job only women do, just because that's a stereotype it picked up from the data it learned from. These kinds of wrong assumptions can lead the AI to make biased or inaccurate statements, further showing how it can get confused when its learning material isn't balanced or reflects outdated stereotypes. The second category, after the misinformation and biases, is knowledge boundary. The vast amount of information AI learns from at the start gives it a lot of facts, but it still has limits. Mainly, these limits show up as not having the latest facts or being experts in specific areas. Even though AI can do well in many general areas, it struggles with specialized topics because it mostly learns from information that everyone can access. It doesn't get much chance to learn from private, expert-level data, so when it runs into questions that need deep knowledge in fields like medicine or law, it can get things really wrong, making up answers because it doesn't know the actual facts. Another issue is that AI doesn't keep learning new facts after its initial training period. So as the world changes and new information comes out, the AI knowledge becomes old. This is a big problem because the world is always changing. If you ask it something based on the newer facts, it might give you an answer that used to be right, but it isn't anymore. Next in line is inferior data utilization. The data AI starts learning from is packed with real-world facts. This allows AI models to hold onto a ton of information, But even with all this info, they can still get things wrong because they don't always use what they know the right way. We're going to look at two big problems here: how they might get confused by seeing two things together a lot, and how they sometimes forget important details. Even though a lot of work has gone into figuring out how AI stores what it learns, it's still a bit of a mystery how exactly they hold on to facts. Recent research shows that instead of deeply understanding everything, AI might just look for shortcuts, called knowledge shortcuts. For example, they might notice two things are often mentioned together and then wrongly assume they are related. This can lead them to make mistakes, like wrongly saying Toronto is the capital of Canada, just because Canada and Toronto pop up together a lot in what they have learned. Mistakes can happen when AI can't properly use the huge amount of info it has. There are two main issues here. First one called long-tail knowledge. When it comes to rare or unusual facts, AI can struggle. It tends up to remember things that come up a lot, but might forget about or mess up the details on less common topics. For instance, if asked to write about a lesser-known historical figure it learned about from Wikipedia, it might get their job wrong, like calling a politician an educator by mistake. And the second one is complex scenario. Using what it knows to figure out complicated question is tough for AI, especially if an answer needs several steps or connections. Sometimes, even if it has the right info, it can't put it all together correctly. This can lead to what's called a reversal curse, where it can answer a question one way but gets confused if you asked it the other way around. And in situations where it needs to use multiple pieces of information, it might have all the facts right in front of, but it still can't come up with a correct answer. Like it knows Mount Everest is the tallest mountain, but can't figure out which mountain would be the tallest if Everest were shorter. Hallucination can also come from training data. The training of AI models, especially LLMs, involves two main parts: a starting phase where they learn general knowledge and understand how to process language, and fine-tuning phase where they were adjusted to better follow what users want. Although this process gives them amazing skills, mistakes in any part can lead to errors in what they produce, known as hallucinations. There are also hallucinations from pre-training. The initial learning phase is crucial for LLMs. They use a special setup called a transformer to learn from huge amount of text. But problems can pop up from the way this setup is designed and how training is done. We'll look into issues from the design flaw and how too much repetition can cause problems. There are two main problems in this area, and that is architecture flaw and exposure bias. LLMs use a design based on something called a transformer, similar to models like OPT, Falcon, Llama 2, and so on. This design has brought a lot of success, but it's not perfect. Some of the problems it includes are inadequate unidirectional representation. In simple terms, these AIs learn by predicting the next word based on the words that came before it, going from left to right. This way of learning is straightforward, but limited because it only looks back, not ahead. This can make it hard for the AI to understand more complex language patterns, leading to more mistakes. Then we have attention glitches. The transformer design lets AIs pay attention to words that are far apart in a sentence, which is usually a good thing, but sometimes this attention system can mess up, causing the AI to make weird mistakes, whether the information is near or far in the text. One reason is that the attention might get spread too thin over many words, especially in longer sentences. Apart from design issues, the way AIs are trained can also cause errors. A notable problem is exposure bias. This happens because during training, AIs always get the correct next words to learn from. But when they're actually being used, they have to guess the next word themselves. If they guess wrong once, it can lead to even more mistakes, kind of like a snowball rolling downhill, getting bigger as it goes. As AI models get better at mimicking human writing, telling real from made-up content is getting trickier. This is a big deal because we rely on these models to give us accurate information. To fight this, experts are working on a way to spot when AI is making stuff, hallucination detection, and tests to see how good they are at catching these slip-ups called benchmarks. So how do we detect them? Making sure AI gives us reliable info is key. Traditional way of checking, like seeing if words match up, don't always catch when AI makes stuff up. We need smarter ways to tell when AI is straying from the truth. Depending on what kind of a mistake AI is making, the approach to finding it varies. Let's dive into how we can spot these errors, focusing on facts and truthfulness. Factuality hallucination detection is catching when AI fibs about the facts it has. We're looking into methods to find these mistakes mainly by comparing AI words to trusted info or guessing when it's unsure. One approach is to check AI statements against trusted sources. This is like fact-checking but for AI. The idea is to break down what AI says, find relevant info online, and see if it adds up. Some methods automate this by pulling in lots of info from the web and using it to check AI's work. Others look for the most reliable sources to clear up the conflicts. There's also a neat tool called FactScore that checks long answers by AI piece by piece against trusted facts. And some techniques improve how we find supporting facts, making sure we're not straying off the topic. Another way to find mistakes is to spot when AI is unsure, even without outside info. This is based on the idea that AI slip-ups come from its own doubts. There are two main ways to do this. The first one is internal states. We can sometimes tell AI is unsure based on the clues from how it thinks, like how confident it is about the words it chooses. Some experts look for the least confident parts of what AI says as a sign it might be making stuff up. Others ask AI to explain something, then see how well it can stick to the story, which helps guess how well it knows the topic. There's also a tactic that tries to trick AI into making mistakes on purpose to see how it reacts. And the second one is LLM behavior. When we can't peek inside AI's thought process, we can still watch how it acts by asking the same thing in a different ways or checking if AI says the same thing twice. We can guess its certainty. Some researchers suggested asking roundabout questions to get more telling answers. There's even a strategy where one AI tests another, trying to catch it in a mistake by asking tricky follow-up questions. Making sure AI sticks to the topic or follows specific instructions is crucial for its use in many areas, like summarizing texts or having conversations. The goal of faithfulness hallucination detection is to ensure AI's response actually match what's asked or given, avoiding any off-topic or contradicting answers. To check if AI is staying true to the source, some methods look at how well the facts in AI response match the original information. These methods vary based on different elements, like specific details, relationships, and overall knowledge. There are multiple metrics. The first one is n-gram-based. Using the original text as a reference, traditional methods like rogue and parent T measure how much the words in AI's response overlap with the source. But because language can be flexible, these methods might not always align with a human judgment. Next in line is entity-based. For tasks like summarizing, making sure the key detail match is important. Some metrics check if AI misses or changes important details, which could mislead the summary. Then we have relation-based metrics. Even if the details are correct, the way they're related might be wrong. Some tools focus on the connections between details, using special models to see if AI gets the relationships right. Next one is knowledge-based metrics. In conversation that needs specific information, it's key to see if AI's response match the provided facts. Some metrics measure how well AI's answer line up with the background information given. Then we have classifier-based metrics. Apart from checking facts, some methods use trained model to tell if AI's response are reliable. These can be split into a few approaches. Entailment-based. The idea here is if AI's response truly fit the source, they should make sense as a natural continuation. While some studies use this approach for summarization, the challenge is making sure that training data matches the task at hand. Advanced methods include tuning models on specific datasets or breaking down the analysis into smaller pieces. Using related data to train these models shows promise, but there's often a gap between related tasks and the specific task at hand. Some researchers have created weakly supervised data or used rule-based methods to improve training. Second metric is called question-answering-based metrics. Using QA methods is a new approach that looks at how information in AI's response matches the source by generating questions and answers. This method varies in how questions are chosen, generated, and how answers are matched, leading to different results. Then we have uncertainty estimation. Similar with what we talked in this video before, mistakes in AI responses can be linked to its own uncertainty. Using Bayesian method or measuring uncertainty through specific metrics like entropy helps spot when AI might be making stuff up. And the last metrics is prompting-based metrics. Leveraging AI's ability to follow instructions, new ways to evaluate faithfulness involve giving AI guidelines and comparing its responses to the source. The evaluation could be a simple yes or no, on whatever it's faithful, or use a scale to rate how well it sticks to the facts. Different strategies for choosing and presenting these prompts aim to refine the evaluation. In this section of the video, we will dive into the world of benchmarks designed to tackle hallucinations in AI. These benchmarks are essential tools that help us understand and measure how well AI can avoid making stuff up, something crucial for ensuring the information it provides is reliable and accurate. They fall into two main categories: those that assess how much AI tends to hallucinate, and those that test the effectiveness of methods aimed at spotting these hallucinations. So let's explore some of the standout benchmarks in both areas. First, let's start with hallucination evaluation benchmarks. These benchmarks focus on checking whether AI outputs stray from reality or the given context, especially when it comes to the facts. They range from evaluating general truthfulness to assessing specific knowledge areas, using various formats to challenge AI. One of them is called Truthful QA. This set of 870 questions across diverse topics tests how truthful AI models are. It uses tricky questions designed to reveal AI's tendency to repeat common but incorrect beliefs. Next one is called Real-Time QA, the challenge by using recent news to ask questions, ensuring AI's response are up to date with current events. Then we have MedHalt, targets the medical field with multiple choice questions to gauge AI's factual recall and reasoning in a domain where accuracy is critical. Then we have Factor. Factor generates benchmarks by tweaking factual statements, creating a direct test of AI's ability to stick to the truth. Then we have Fresh QA, challenges AI with questions whose answers may change over time or are based on incorrect premises, testing its ability to keep up with current knowledge. Hallucination detection benchmarks are all about testing how well various methods can identify when AI is making things up, with a focus on specific tasks or domain. In this area, we have Self-Check GPT, uses a synthetic Wikipedia articles to create a dataset for sentence-level hallucination detection. Then we have HalluEval, combines automated generation with human annotation to test AI's ability to recognize hallucinations across general and task-specific queries. Then we have Bamboo, introduces datasets for detecting hallucinations in longer texts using academic papers to generate examples. Then we have Felm, covers a broad range of domains using responses generated by ChatGPT to test for factual accuracy across various fields. PhD focuses on passage-level detection, categorizing entities by their prominence in Google search to challenge AI with a mix of factual and fictional scenarios. Then we have ScreenEval, expands to long-form dialogues, annotating TV scripts and summaries for factual inconsistencies. RealHole tackles question-answering tasks, dividing them into closed and open categories based on whether reference text is provided. LSum concentrates on summarization tasks, annotating the factual consistency of summaries produced by different AI models. Now that we understand how hallucinations happen and how to detect them, let's talk about mitigating data-related hallucinations. Data-related hallucinations usually stem from issues like bias or misinformation baked into data AI trains on. Here, we're going to explore how to clean up this data to reduce errors. To cut down misinformation and biases, the focus is on gathering accurate data and cleaning up the existing data. It's vital to keep training data factuality correct to prevent AI from learning wrong information. This can involve manually picking reliable data or using data from academic or other trusted sources. Upsampling factual data during training has also shown promise in keeping AI truthful. We can also do debias. This involves removing or reducing biases in training data, whether they're about repeating information too often or societal biases. Techniques range from simple duplication checks to sophisticated methods that use AI to find and remove biased information. Given AI's limitations based on what it has learned, bridging knowledge gaps is key. Approaches include directly updating AI's knowledge base or using external sources for additional information. This involves updating the AI's stored knowledge to correct errors or add new information, whether by tweaking the AI's internal workings or using external tools to inform its responses. One of my preferred ways is retrieval augmentation. This strategy uses external databases to supplement AI's knowledge in real time, enhancing its accuracy by pulling in relevant information as needed. We categorize the methods to mitigate hallucinations using retrieval augmentation in 3 types, including one-time retrieval, iterative retrieval, and post-hook retrieval. Now that we learned about mitigating these hallucinations, there are also some other things to address, like context consistency. Efforts to improve context consistency aim to make LLMs output more faithful to provided instructions and context. Early work in areas like summarization and data-to-text generation introduced methods like confident decoding, which adjusts attention to the source based on a confidence score to reduce context-related hallucinations. Recent approaches in the area of LLMs, such as context-aware decoding, called CAD, attempt to refine output distribution to enhance focus on contextual information. However, emphasizing context too much may limit diversity. Innovations like dynamic temperature adjustment during decoding and knowledge-constrained decoding, KCD, strive to balance faithfulness with diversity by adjusting the model's focus or employing token-level hallucination detection to guide generation. And the last important step is logical consistency. Ensuring logical consistency is crucial for LLMs to provide coherent and consistent responses, especially in complex reasoning tasks. Strategies like knowledge distillation and contrastive decoding work to improve the self-consistency of chain-of-thought reasoning, eliminating shortcuts and enhancing the depth of rationale. These methods help LLMs avoid reasoning errors and ensure that generated content follows logical steps correctly. After exploring various methods related to the causes, detection, and mitigation of errors, we circle back to the initial question. Is ChatGPT biased? Considering the numerous ways it might get an error, it's highly improbable that ChatGPT acts with intentional bias. Yet, we cannot dismiss the potential for unintentional human errors or biases introduced during its fine-tuning, nor can we overlook OpenAI's responsibility to address such issues. Ultimately, everyone deserves freedom and equality, and AI systems like ChatGPT should reflect these values. Links to all reference studies will be included in the video description. For those interested in diving deeper, our free educational platform, TechLingo, offers resources on technical literacy. Thanks for watching, and I hope you have a wonderful day.